47 minutes of debugging, and a near incident on a Friday afternoon, all because of a single character mismatch. The playbook ran perfectly, every task reported changed, but the servers never reloaded their config. Let's break down Ansible Playbooks Explained, how it works, and the exact mistake behind that failure. An Ansible playbook is a YAML file containing a list of plays. Each play maps a group of hosts from your inventory to a sequence of tasks that define the desired state of those hosts. The structure is deliberately simple. You declare what you want, not how to achieve it. Ansible figures out how to get there. Idempotency is the property that makes a playbook safe to run repeatedly. Run it once. Ansible installs Nginx, deploys the config, starts the service. Run it again immediately. Ansible checks each state, confirms everything matches, reports OK on every task, and exits without changing anything. This property is what enables you to use Ansible as a continuous enforcement mechanism. Here's a complete idempotent playbook. Notice the apt module pins the version, the template module validates the config before writing, and the service module checks state before acting. The handler reload Nginx service is notified only when the template task reports changed. This is the pattern you should follow. A play is the top-level unit. It has a hosts field, a become field, a vars block, a tasks list, and a handlers list. Tasks are the individual units of work. Handlers are special tasks that only run when explicitly notified by another task that reported changed. Templates are Jinja2 files that Ansible renders at runtime. This example shows two plays, block rescue error handling, and meta, flush handlers. Notice how the second play uses a block to wrap deployment tasks, a rescue to roll back on failure, and flush handlers to ensure the app restarts before the health check runs. Handlers run at the end of a play by default, but flush handlers forces them to run immediately. Most Ansible playbook failures in production share a common root cause. The engineer treated the playbook like a bash script. The shell module is the most common symptom. Variable precedence is the second major category. Version pinning is the third. Each has a specific, mechanical fix. Here are the production-safe alternatives. The file module creates directories idempotently. The apt module with a pinned version prevents silent upgrades. The line and file module manages a single line in a config file without appending duplicates. These modules exist precisely to eliminate the class of bugs the shell module creates. Ad hoc commands are fine for debugging a single box, but for anything repeatable, deployments, config changes, compliance checks, ad hoc is a liability. You lose history, audit trails, and introduce drift. Playbooks solve this. They are version-controlled YAML files that define the exact state every machine must match. This playbook orchestrates a zero-downtime deployment. Drain connections, pull new container, restart service, re-add to load balancer. One file, no manual steps, no forgotten commands. This is the power of playbooks over ad hoc commands. Ansible playbooks are YAML. YAML is whitespace sensitive. One tab character where a space belongs and your playbook silently fails, or worse, applies the wrong module to the wrong hosts. 3 rules eliminate this. Use 2 spaces, every play starts with a dash and a name, and separate lists from dictionaries clearly. Here's a properly structured playbook. Notice the consistent 2-space indentation, the name, for each play and task, and the clear separation between the task list and the handler list. Run Ansible Playbook syntax check before every production run. Add a grep-based CI check that fails the build if any notify. Value does not match a declared handler name. This catches silent handler failures before they reach production. Ansible matches handler names as exact, case-sensitive strings. A notify, reload Nginx will not trigger a handler named reload Nginx. The mismatch is silently ignored. Always use consistent casing, e.g., all lowercase with underscores, and validate with list tasks. Instead of relying on exact handler name matching, use listen topics to group handlers by purpose. Multiple handlers can listen to the same topic, and tasks notify the topic name. This decouples notification from handler names and reduces typos. This is the same issue we highlighted at the start. Here's exactly why that happened. The playbook updated config files and every template task reported changed. But the service never reloaded. The notify line read reload nginx lowercase r. The handler was named restart nginx capital R and different verb. Ansible performed an exact string comparison, found no handler named reload nginx, and silently continued. No error, no warning, no mention in the output. The notify directive referenced reload nginx, but the handler was named restart nginx. Ansible matched exactly, found nothing, and silently did nothing. The fix is straightforward. Standardize handler naming with a team-wide convention. Use a pattern like reload nginx service with consistent capitalization. Add a CI check that greps every notify. Value and compares it against declared handler names. A mismatch fails the build. Better yet, use listen topics to group handlers by purpose rather than relying on name matching. This is the exact mistake from the incident. The notify value reload nginx does not match the handler name restart nginx. Ansible silently drops the notification. The playbook reports success, but the service never reloads. Always ensure exact, case-sensitive matches. Using state, latest in a production playbook means Ansible might upgrade nginx from 1.24 to 1.26 on a random Tuesday without anyone noticing until the service breaks. The playbook showed changed, but nobody checked what version got installed. Pin versions explicitly and manage upgrades via a separate, deliberately triggered playbook. The shell module runs the command every time, unconditionally, and always reports changed. After 30 days of cron runs, you'll have 1440 identical, changed entries in your CI log, making it impossible to distinguish real changes from noise. Always use the file module for directory creation. To diagnose handler issues, first check exact handler name spelling and case. Run Ansible Playbook list tasks to see the full task list including handlers. Use grep notify playbook IML and compare every notify value character by character against the handler names. If you need to confirm a handler is being reached, add a debug task inside the handler block. These 5 commands diagnose 80% of playbook failures. Run syntax check to catch YAML errors. Use list tasks to verify handlers appear. Use grep to compare notify values against handler names. Run check diff to see exactly what changes between runs. Let's run through some common interview questions. Difference between play and playbook. Playbook is the file, play is a mapping inside it. What is idempotency in Ansible? Property that running a playbook multiple times produces the same result. What happens if you notify a non-existent handler? Ansible silently does nothing, no error or warning. And a few frequently asked questions. How do I make a playbook idempotent? Use dedicated modules like apt, template, service instead of shell. Why did my handler not run? Check for case-sensitive name mismatch between notify and handler name. How do I debug variable precedence? Run Ansible inventory, host vars to see resolved values. Let's recap the key takeaways. Playbooks are declarative, not imperative. Idempotency depends on dedicated modules. Handler names are case-sensitive exact matches. Use flush handlers for dependent tasks. Ready to go deeper? Up next, Ansible roles and best practices, then Ansible inventory management, then Ansible variables and facts, and Ansible conditionals and loops. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.